Right, ready? Oh, cross, it's a bloody huge book. Oh, no swearing. Atlas of the World. Here we have the universe. So many stars you can't count them. And we've got the planet in the universe. Looking a bit sad. Atlas of the World. We've got a star map. And this is the one. We've got the sun and the planets all in our solar system moving in pretty standard elliptoid track around the sun. And there's the Earth and there's the moon. With our spin, which is very crucial at the moment, will the moon impact our spin? We think so. Right, these are the tracks of the sun and all of the planetary partners orbiting the sun. There are all the planets. There's the surface of the moon. These things are not as important as you think right now. What we want is this. Now this is a beautiful picture. The sun, the earth, spinning that way, going around the sun that way, on what we call the lambda ride. We think universal rhythms, the thing that carries us around the sun, that we're on a sort of a standard sort of orbit that sits in universal rhythms right here. And then we're on a tilt. We don't rotate that way as we go around. We rotate on a tilt, and that's our axis of spin. And that gives us sun intensity changes for summer and winter, and gives us the seasons, right? And the moon gives us the pull for the tides. We get 2 tides a day because the moon pulls all the water towards her because of gravitation between the 2 planets. Well, we call her a planet right now. So we have the tides because of the moon, and we think actually the moon affects our spin. Now, our tilt affects our spin and our temperatures. And if we drop off what was our original spin, because we don't have these weights here and here, then everything changes with our spin. If we have a nice tight spin, because we're weighted properly and our axis is right, then we spin well. And if we don't spin well, we wobble. And that's going to upset people wobbling as we rotate and spin. What's the other issue about our spin? Leaving you to think about it. Because here we go. There's our axis. About the 1600 she tilted. We're worried about slowing down. We're worried about slowing down too much. So much so that we don't have night and day. That we have the dark side of the planet, well, like we have the dark side of the moon. Okay, we don't want that. Not to scare you, but we're in deep shit. No swearing. Now we have a map here to show you the structure of the planet. There's a subduction zone. Remember yesterday I said that there was a spreading zone and the magma goes this way. in that way at the ocean floor, and it pulls the ocean floor underneath a continent like South America, and then it pushes up mountains. Yeah, and we have the spreading zone around about there, and that's the spreading zone. So we have the magma underneath, and we call this the asthenosphere. It's hot, it's molten, you can see it erupting out of volcanoes. Kilauea at the moment in Hawaii has got like magma spurting out, so you can see it. We call this the lithosphere. This is basalt, it's ocean floor rock, and then we have lighter continental rock. So the way that the Earth spins depends on weight, and obviously when you look at the world map, you don't have an even distribution of heavy lithosphere. This is thin, thick lithosphere, which is continental rock above the water, which is lighter and thicker. We've got like a big continent here, and we've got a huge ocean here and a narrow ocean here. So we have sort of, all of this is drifting and moving around, all of these things, and this Indian subcontinent is pushing up into the Himalaya. It's moving northward. We've got subduction zones here, we've got subduction zones there, we've got a whole big messy bit there, we've got a messy bit in here. We've got trenches, we've got little underwater volcanoes, we've got all sorts of things happening, but basically we've got a whole layer of molten rock underneath a floating lithosphere that breaks and sinks and lifts and changes according to the pressures of the planet. As we move water around, all of this gets affected, and it affects our spin. So we're kind of, there's another one showing subduction. Yeah, and then look at the whole thing. It's not an even mass distribution of the lithosphere in terms of basaltic, oceanic, thin crust, and what is an enormously thick crust here. Now we have a theory that from Pangaea, all of these things are spinning out into a more even distribution as far as the continents go, and we're in constant motion. When it comes to the spin, we'd like to see that we have one, because we don't want to have a dark side of the Earth like we have a dark side of the Moon. We want to spin. And it's wind and ocean currents that drive the spin, and so we have to have this sorted out. Right.